21, which has to do with reading rates, and it's all regarding the idea of a sampling distribution. Okay, so some of you may not be this far, and that's okay, but Jen had this question, so I wanted to go over it. And her big question was the one down the bottom for letter F. There is a 5% chance that the mean reading speed of a random sample of 20 second grade students will exceed what value? So they're basically asking you what X value would it have to be for there to be a 5% chance that the mean would be that or above. So let's check this out. So what we're going to have to do, and I'm going to kind of have a piece of paper over here just to kind of help take a look at this. Let's just talk about what we have here. So in this problem, we have that the mean is 90 words per minute. And I'm sorry for the lighting, it's not that great. And that the standard deviation is 10 words per minute. Okay, now remember, when it comes to a sampling distribution, the mean of the sampling distribution is going to be the same as the mean of the distribution itself, as long as it's normal. But the standard deviation of the sampling distribution is going to be the standard deviation divided by the square root of whatever the sample size is. So for that here, we're going to have 10, and in this case, it's 20 second grade students. The letter F down there. Oops. Yep, it's 20. So we're going to do the square root of 20. Okay, and excuse my arm. I don't have my other calculator, so I'm going to use my calculator here. I know you can see my arm right now, and that's kind of weird, but we'll go with it. So it's going to be 10 divided by the square root of 20. Boom. And we get 2.236. We'll round it off to 1. I think the book has liked it when you have 4 decimal places. We'll call it 2361. So there we have the mean and the standard deviation of the sampling distribution. So let's go back over here. So remember what your normal distribution looks like. It looks like a nice pretty bell shape. And again, my drawings are never the best. But if this is our sampling distribution, now the mean is 90. We're going to pretend this is the x-axis here, and our standard deviation is going to be the 2.2361. So what they're saying is, okay, 5% is not very much, so we're going to put maybe our line over here, and we're like, what would this x have to be? I'm going to put x question mark for this area in here to be 5%. And remember, our areas are going to be expressed as a decimal. So 5% is the same as this area here being 0.05. So it's like we're going backwards in our z table. We're going to say, you know what, let's put the z bar underneath here, turn that x-axis into a z-axis, and say what z-score would this have to be? Because really this area here, the only way we can do that is if we know the z-score, but we can go backwards in our table. So I'm just going to, again, excuse my arm, but I'm going to go over here, I'm going to go down, and let's take a look. I think I bookmarked it at our table. There's our table. I'm going to zoom out just a tiny bit. So I'm looking for in a right area here. Ooh, am I frozen? Oh, there I am. A right area here of 0.05. Now remember that in the z-table only finds areas to the left. So really the area over here, if this area is 0.05, and I think that my webcam is just being weird. If the area to the right is 0.05, then my area to the left is going to be 0.95. And that should pop up fairly soon. So if the area over there is 0.95, what we're looking for here is we're going to look in our table and we're going to look for as close to 0.95 as we can inside the table. So I'm going to say, okay, here inside the table, how can I get close to 0.95? So I'm going to kind of look around. And if I look around, I actually have these two numbers, 0.9495 and 0.9505. And basically, you know, I'm going to have to go straight in the middle because 0.95 is directly in the middle of those two. So if we take a look at the z-score that corresponds to that, if I go over here, that means that I'm going to have a z-score of 0.16, and I'm going to go in the middle of these two. Oops, where am I? There I am. Right here. In the middle of these two, so it would be 1.645. Let me just restart my dog cam here because I think that it's frozen. Let's see if we can get it back. Well, there it is. All right. Okay, so we're going to call this z-score. Z is going to be, I'm going to undo the question mark here. It's going to be 1.645. So I'll say, okay, that's great. Now I know that the z-score is 1.645, but I need to know what the x-score is. So it's like we're going backwards. We know that z equals x minus the mean. I'm just going to write these out here over the standard deviation. So I'm going to go backwards. I'm going to plug everything in. So now I know 1.645 is x minus my mean, which is 90 for my sampling distribution. And the standard deviation is 2.2361. And I will solve for x. So I think from here you might be able to take it. If you have any trouble with solving this, just let me know. But you're just going to multiply by 2.2361 to get that cleared in the denominator, and then add your 90, and you should have your x score. So again, please feel free to ask any questions. I'm sorry this was kind of put together hastily, and thank you for being so good about the craziness going on here. We've had a lot of excitement, but it's good excitement, so that's always a great thing. Let me know if you need any more help.